So here we have the data from 1970 to 1980. So you can see here are 11 observations. So these are the data. You can see all the data x1, x2 and y, and I'd like to open all data. I'm opening data gradually. So this one is the time series data from 1970 to 1980, and these are the three variables x1, x2 and y. So what you can do, you can copy it and you can insert it and you can follow me the way I'm doing here. If you want, yes, you can do it. Okay, what is my plan? My plan actually to make a VAR model. To make a VAR model. What is called VAR? Vector autoregressive model. That is my plan to do it. So meaning that if I do the VAR, so there will be three model. First model will be y, will be dependent variable. X2 will be also dependent variable, and x1 will be also dependent variable. Meaning that in the VAR model, so there will be three model, or in the VAR model there will be three regression model. One is by x1, and one is by x2, and one is by x1. So I proceed with the VAR model. How to make a VAR model? What I am doing, I am going to quick. I am choosing quick, and I am choosing estimate VAR. I want to estimate VAR. I click on it, and here I assume that all the variables are endogenous as it is. So I first put y, and then put x1, then I write x2, and here I choose lag intervals. Suppose I choose 2 lags, and the data is from 1970 to 1980. That is here, and here is VAR type. VAR type, I choose the first one, which one is unrestricted VAR. That I choose, and that is already here, right? Already selected by default. So now I click on the OK. So the result is coming up very soon. Yes, this is the outcome of the VAR model. You can see from here. This is the outcome of VAR model, that you can see from here. So and what is happening here? Outcome. Okay, you see the outcome. So this one, and yeah, as I said, this is vector autoregressive model, and it is here, right? And here standard error means this one, second bracket, and t statistics means third bracket. So here you can see y is dependent variables, x1 is the dependent variable, and x2 is another dependent variable. So meaning that we have three three regression model. Suppose I talk about this one, first one. So this one is the independent variable lag 1, and this one is the second independent variable, which is lag 2. And what we have done here, we have chosen 2 lag. So that is why here are 2 lags for each variables. And also x1 and x1 has 1 lag and x1 has lag number 2. It is here. Then x2 also lag 1 and x2 is also lag 2. And finally we have the constant of this regression model, right? So in the similar way, x1 has also independent variable. It is this one and this one, this one, this one, this one, this one, and C, constant, right? x2 has also, x2 is a dependent variable, and it has also 1, 2, 3, 4, 5, 6 independent variables and a constant. Okay, now suppose I take this one. What does mean by this? This one is the coefficient of this variable, and this one is the standard error of these variables. And you see this second bracket means this one, standard error, and this one is the t statistics, that is under third bracket. Okay, how to get this value? This coefficient divided by standard error, we can get the t value all the time. Then in the similar way, this is coefficient, this is standard error. So this divided by this, I can get the t value. Then similar way, this divided by this, I can get the t value. In this way, suppose I talk about this one, this divided by this, I can get the t value. Okay, so here in the whole system, in the whole VAR model, how many coefficients are here? So I check one by one. 1, 2, 3, 4, 5, 6, 7. 7 coefficients are here for one model. So one regression model has 7 coefficients. The second model also got 7, and third model also got 7. So total system or total VAR model has 21 coefficient in total. How many coefficient in the total VAR model or in the total system? 21. Okay. Now my question is that, suppose whether these variables, is it significant to explain why? Is it significant to explain why? So to tell the answer, to know the answer, we must know the p-value. And what is the guideline? If the p-value is less than 5%, then a particular variable is significant. to explain dependent variables. And if the p-value is more than 5%, then that particular independent variable is not significant to influence the dependent variable. That is the guidelines. But here, my question is that is this independent variable is significant to explain this dependent variable? We cannot answer the question because here is no p-value. Only t-value is here. Here is no p-value. So it is difficult for us to answer the question. But if I know p-value, then we can say whether this variable is a significant to explain why. I can say another example. Suppose x1 is this coefficient, right? Is this coefficient is a significant to explain this one, this x2? We cannot also say because we do not know what is the p-value. So we must know p-value. Okay, so how to know about p-value? So we go to system equation. We go to system equation to know the p-value. Okay, I click on the proc. I click on the proc procedure and I choose make system, right? And then I choose order by variable. I choose this one. You can follow me the way I am doing here. And you can see we have the three model where y is dependent and these are all independent variables. And you can see it is the, suppose it is one variable, lag of 1, and it is the coefficient. So this multiplied by this, and suppose it is the lag 2 of y variable and corresponding coefficient. In this way, we have the 7 coefficient for the first model. And in the second model, where the dependent variable is x1, that start from C8 because it is ended at C7, so it start from C8, and this is the corresponding variable. Then C9 is the next coefficient and corresponding variable, and finally C14 is what? The constant of this model. Okay, third model is x2, which begins from C15 because C14 from the C14 I start from C15. So in this way the final one is C21. So it start from C1 and finish at C21, meaning that in the whole VAR model there are 21 coefficients. Okay, now how to estimate the p-values that we want to know. To estimate the p-values of this 21 coefficient, you choose on the estimate, choose on it. After clicking estimate, you get the result, ordinary least square method, right? Because normally we use the ordinary least square, OLS. and the sample is 1970 to 1980. So I click on the OK. So you can see the result of system equations. System equation. The results are coming here. And you can see it starts from C1 until what? Until C21. Right? From C1 to C21. Because we have 21 coefficient in total, and that is here. Okay, and you say, what about the first one? Okay, this is the coefficient, this is standard error, and this is t statistics. And how to get this one? This divided by standard error, I can get this one, and this is the corresponding probability, right? And so what we can see at the below we can see that is the equation number 1, that is y is the dependent, right? And you can see C1, C2, C3, C4, C5, C6 and C7. So that is the equation number 1. Then equation number 2, or model number 2, where x1 is the dependent variable. So it starts from C8 because the whole thing ended at C7. So I start from C8, C9, C10, C11, C12, C13, C14. So this C14. Then the third equation, that is here, third equations, right? So that is the x2 is the dependent variable, and it starts from C15, right? C15, 16, 17, 18, 19, 20, 21. So total we have 21 coefficient, right? And we know about all these coefficient. That means we know the p-values of all these 21 coefficient that you can see from here. All the p-values are here from C1 p-values and C21 the p-values are all here.